Okay, so this video is going to be a follow-up of the one that I just did. So the previous one I just covered the rules and definitions of exponents, and this one I'm actually going to do examples to show you how we use these different rules. I'm going to do 6 problems, not really one for each rule, but it's just going to use some of the harder ones to see how you can combine them. Okay, so for the first one that we're going to do is a power-to-power rule. The product rule. If you're using the book that we have, it's on page 346, number 21. So the problem is x to the 7th power times x to the negative 2 power times x. So we need to simplify this, and so we have to use the product rule. And the product rule was any real number that's not 0, x to the n power times x to the n power. We add the n exponents to get our answer. So all we're going to do is rewrite our variable x, because that's the common variable here, and we're going to add our exponents. So 7 plus negative 2. If we don't see an exponent, the exponent's always 1. So we add that. Okay? 7 plus negative 2, that's like 7 minus 2. So that gives us 5 plus 1. So our answer is going to be x to the 6th power. And that's the product rule. How you combine multiple variable products raised to the exponents. Okay? Power-to-power rule. This would be number 27. A to the negative 6th power raised to the 3rd power. I'll write that a little bigger for you. Okay? So our power-to-power rule was that if we have exponents raised to another exponent, we multiply our exponents together to get a simplified answer. So we take A, we multiply together negative 6 and a positive 3. Remember, whenever we multiply positive and negative numbers together, all we have to do is count the number of negative signs in the problem. If there's an odd number of negative signs in the product, then our answer is going to be negative. If there's an even number of negative signs in the product, the answer will be positive. We have an odd number of negative signs, so we know our product will be negative, and 6 times 3 is 18. Now, we're not done simplifying yet, because our first definition that we learned was that anything raised to a negative power, we need to rewrite with a positive power. So we write the reciprocal of A, which is 1 over A, and now we can raise that to the positive 18 power. So that is an example of the power-to-power rule. All right, we're going to skip down to number 35, and I'm going to show the product-to-power rule. So this is negative 6a raised to the 5th power times b to the 3rd power, all raised to the 2nd power. So we have an exponent touching a parentheses. That means that exponent is distributed to everything inside the parentheses. So I'm going to distribute negative 6 squared times a to the 5th power squared times b to the 3rd power squared. So I distribute that 2 to everything, every part inside. And then I simplify these. So that was our product, and now we do power-to-power rule. So negative 6 to the 2nd power, or negative 6 squared, is negative 6 times negative 6. There's a negative inside the parentheses, so we count that 2 times. That means it's going to be a positive 36, because there's an even number of negative signs in that product. Then we have a to the 5th power squared. Remember, our rule for power-to-power is that we multiply these two together. So we get a, 5 times 2 is 10. And then we get b to the 3rd power raised to the 2 power. So we multiply 3 times 2 together, that gives b to the 6th power. And that is as simplified as that one gets. So 36 times a to the 10th power times b to the 6th power. All right. Now we're going to do a quotient rule. And this one can get a little sticky, so we're going to go a little slower with this one. 11 to the 6th power times b to the 8th power is your numerator. In your denominator, you have, or I could say divided by, 11 to the 4th power and b to the negative 4th power. So our quotient rule was that it's the opposite of the product rule. We subtract the exponents instead of adding them. So we take the ones where the variables are the same. Our 11s are the same, so that's what we're going to work with here. I'll write it down here. No, I'll write it here. 11, 6 minus 4 times b, and we subtract those two exponents. 8 minus a negative 4. Okay, whenever we have minus and negative, they both become positive. So I'm going to bring it down here. 11, 6 minus 4, so it's 11 to the 2nd power times b, 8 plus 4 to the 12th power. Now we have one more thing that we need to do. Because this is a real number, it's a constant number, we can actually square it. We don't ever expand the variables, but when we have real numbers, we want to go ahead and expand that. So 11 squared is 121. So the answer is 121 times b to the 12th power. So that's basic quotient rule. I just suggest you work slow. They might look a little intimidating at first, but just work slow and go step by step. All right, the next one's number 50. It's the quotient to power rule. This gets a little bit harder. So we have 5x to the 12th power times z in the numerator. We have x to the 4th power times y to the negative 7th power times z to the 5th power, all raised to the negative 1 power. I chose this one because it had a negative 1 in the exponent. Alright, so first thing first, I like to distribute my exponent out here and then see what I'm working with. So what I'm going to do is I'm just going to rewrite everything with that negative 1 exponent. So I'm going to apply it to the 5 to the negative 1 power. And I like to put my little dots in there for multiplication. Just for me, it helps me to separate them a little bit better. So I have x times 12 raised to the negative, or x to the 12th power raised to the negative 1 power, and z to the negative 1 power. That's the x, or that's the numerator. Then I need to distribute that down here to the denominator. So I have x to the 4th power raised to the negative 1 power. I have y to the negative 7th power raised to the negative 1 power, and z, little dots, to the 5th power raised to the negative 1 power. Okay, so now we apply our power to power rule. So what I'm going to do is I'm going to apply each of these, and then if there's any ones that are in common like x and z, then I'll combine them at the end. So I get 5 to the negative 1 power. I don't have to do anything with that one. These two I need to multiply together. So I have x to the, 12 times the negative 1. That gives me the negative 12th power times z to the negative 1. Then I have down here in the denominator x, and then my power is 4 times negative 1, so that gives me negative 4, times y. Y is going to be raised to the, we have negative 7 times negative 1, so that gives me a positive 7. Remember, we have an even number of negative signs, so that gives us a positive number. Then we have z raised to 5 times negative 1. Gives us negative 5. So now, if we have anything that's the same on the top and the bottom, we need to use our quotient rule and simplify that further.